So we will resume the video from this numerical. I guess we've tried this. This was the last question from the previous lecture. So the question was, find out the net charge and capacitance. Okay, find out the charge across each capacitor and the potential across each capacitor. Okay, so let's find out the equivalent capacitance. Okay, so what is the formula for equivalent capacitance? For parallel it was C1 plus C2, and for series it was 1 by C1 plus 1 by C2 plus 1 by C3, like this. All right, so for particularly this section, what we need to do? CP, all right, capacitance in parallel. What is the formula? C1 plus C2. So C1 is 6 plus 3 equals to how much? 9 microfarad. Okay, so 9 microfarad is the formula, is a answer for this particular section. So what is equivalent? So we have to put a single capacitor in place of these two capacitors, so which have a value of 9 microfarad. So that is the physical meaning of equivalent capacitance. Equivalent, that means you have to put one capacitor in place of two capacitors. All right, so this is the answer. Now this and 9 are in series combination. So what is the formula for series combination? 1 by C1 plus 1 by C2 plus 1 by C3 equals to what? Let's suppose 1 by CS. S is the equivalent in series. So 1 by 12 plus 1 by 4 plus 1 by 9 equals to 1 by CS. So what's the LCM? And you can find out the LCM. I guess this would be 36. Okay, 36 might be the LCM. You can calculate it after pausing the video. All right, so okay, 3 12 is 36. So this might be the answer. What is this? 16, I guess, right? 16 by 36 equals to 1 by CS. 4 is a 16. So 1 by CS equals to 4 by 9. CS equals to 9 upon 4 microfarad. This is the equivalent capacitance of the network. All right, so equivalent capacitance is how much? 4 upon 9 or 9 upon 4. This is the answer. Okay, so right now you have to calculate the charge. What's the charge? Okay, now Q equals to CV, I guess. Q equals to C times V. C is 9 by 4 and V is 10. Q equals to CV. Q equals to 2 2s are 4, 2 5s are 10, 45 by 2. Okay, 45 by 2 is the answer. Microcoulomb. This was microfarad, so this will be how much? Microcoulomb. So this is the charge, 45 by 2. This is the charge, and this charge will be what? This charge will be across this and this as well, since they are in series, and in series combination the charge remains constant. The charge across the series combination remains constant. That's why the 45 by 2 microcoulomb of charge will be in this and as well as this. Okay, so this is the charge in this combination. Okay, now we need to calculate the potential across each capacitor. Okay, potential across each capacitor. What would be the potential? The potential would be like V equals to Q by C, I guess. So you might write a line after this. This charge will be across C1, C2 and this whole branch C3. Let's suppose this is C3. Okay, now let's calculate the voltages. Let's name this voltage across this is V1, is V2, this will be, let's suppose, V3. Now what is the formula? V equals to Q by C. Q by C1 for this. Q is what? Q is 45 by 2 upon C1. C1 is how much? 12. This is the voltage. 45 by 12, 2 into is 45 by 24, all right, a volt, this much volt. Likewise, the voltage across this would be V equals to Q by C. V equals to Q by C. Q is how much? 45 by 2. 1 C is 4. The answer would be 45 by 8. 45 upon 8 volt. And across this, for this particular branch, what was the capacitance? The capacitance was 9. So what would the voltage? Let's name this V3. Okay, I've already named it V3. V3 equals to how much? Q by C. V equals to Q by C. Q is 45 by 2. C is 9. Okay, C is 9. V3 how much? 5 by 2. Okay, 5 by 2. So this would be the voltage across each capacitor. Voltage across each capacitor is this. Now this is the voltage across V1. This is the voltage across this capacitor C2, and this particular V 5 by 2 volt is across this. What's the meaning? The 5 by 2 voltage will be in this as well as in this, since these two are in parallel combination, and in parallel combination the voltage remains same. So the 5 by 2 voltage will be across this and across this as well. So this was the problem. This was a solution for the last problem, the last lecture's final problem. And let's do another problem. All right, let's do another problem. And the problem is like find out the charges on each capacitor and the voltage between the capacitors. All right, so voltage and charge, same problem like the previous one. So let's draw the circuit diagram. This is C1, this is C2, this is C3, and this particular end is grounded. Okay, and this particular end is connected with 90 volt. This is C1, C2, C3. C1, C2 and C3. All right, so the C1 is having 20 microfarad, C2 is having 15 microfarad, and C3 is having 30 microfarad. Find out the charge and potential across each capacitor. Like the previous one, the same problem but slightly different. And this is grounded. All right, so ground, you already know the meaning of what's ground. Ground means 0 volt. So the potential difference across this end, let's suppose this is A and this is B. What's the potential difference between A and B? 90 volt. All right, 90 minus 0, that's the difference between the potential is 90. So you can pause the video and try this problem. All right, so let's solve this right now. So for equivalent capacitance, you can see all of these are in series. So what is the formula for series combination? For series combination, the formula is 1 by CS, 1 by C1 plus 1 by C2 plus 1 by C3. C1 is how much? 20 plus 15 plus 30. All right, so what would be the LCM? Particularly, what would be the LCM of this thing? 30, 15, 20. $60. All right, 60 the LCM, I guess. So you can skip the part if you can do this orally. All right, so 60 is the LCM. I guess this is correct. And 9 by 60. 9 by 60 is 1 by CS. So 60 upon 9 is the answer, I guess. 60 upon 9 or 3 by 20. So what would we see? 20 by 3 microfarad. 20 by 3 microfarad is the answer for the equivalent capacitance. Okay, 20 by 3. So charge across each capacitor. All right, what is the formula for charge? Q equals to CV. Q equals to CV and Q equals to CV. So you can play the video at 1.25 or 1.5x, as I'm teaching too much slowly, I guess. Q equals to CV. Q equals to C times V, and C, as we have found out, 20 by 3. The voltage is what? 90 volt. 30. All right. 3 to the 6. 600 coulomb is the charge. 600 rather microcoulomb, as these are of microfarad. Microcoulomb is the charge across each capacitor. 600 is the charge. All right. So 600 is the charge, and this 600 charge will be across this, and this. The same 600 charge will be across the C1, C2 and C3, since all of these are series combination. And as I'm repeating from the first lecture, in series combination the charge remains the same throughout all of the capacitors connected in series. Okay, let's calculate the voltages across each capacitor. What's voltage? V equals to how much? Q by C. V1 equals to Q upon C1. Q is 600, C1 is 20. Okay, so 30 volt. Okay, and V2 equals to Q by C2. Q by C2. C2 is how much? 15 char. And V3 equals to Q by C3. Q is how much? C3 is 30. 20 volt. So these are the answers for the voltage across each capacitor, C1, C2 and C3 capacitors. Okay, so you can cross check whether you have done it correct or not by what? Is 30 plus 40 how much? 70. 70 plus 20 is what? 90, and we have applied how much voltage? 90 voltage. So we have done it correct. All right, so since sum of all the voltage will be the equals to the applied voltage, so this is the answer. All right, so let's move on to the next question, and I'm dictating the question as there won't be anything in the screen, as I won't be able to edit the whole video since I'm recording on 4K, and editing it on 4K in mobile phone will be tough, and I'm trying to shoot this video in one take. All right, so let's do the next problem. And the next problem says the charge on 6 microfarad capacitor is 8 microcoulomb. All right, so you can write it. I'm dictating. The charge on the 6 microfarad capacitor is 8 microcoulomb. Okay, then find out the potential drop across the 4 microfarad. Find out the potential drop across the 4 microfarad. And what's the question? What's given? The charge across the 6 microfarad capacitor is 8 microcoulomb. Okay, so let's draw the circuit diagram at first. The 4 microfarad capacitor is this. This is 4 microfarad capacitor, and 6 and 12. This is 12 and this is 6, and this is 4. This is 4 microfarad. This is 6 microfarad, and the top one is 12 microfarad. 12 microfarad. Okay, and this is between the points A and point B. The charge on the 6 microfarad capacitor is 8 microcoulomb. 6 microfarad capacitor is 8 microcoulomb. Charge equals to 8 microcoulomb. Find out the potential drop across the 4 microfarad. Potential drop across this. What is the potential drop? Potential drop across this. Okay, so this is a question. You can pause it and try. All right, so let's do this right now. At first, we will find out what? We will be finding out the voltage. Okay, so what's the voltage across this capacitor? What's the voltage across this 6 microfarad capacitor? V equals to how much? V equals to Q by C. Okay, so let's do this at first. V equals to Q by C. All right, Q by C. Q is how much? 8 microfarad. Q is 8 and C is 6. 8 by 6, that means 4 by 3 voltage. 4 by 3 voltage is this particular. Let's name this C1 and then name this C2. Okay, let's name this how much? C1. Let's name this C2, and let's suppose this is C3. So this is C1 and this is V1. And let me tell you, the V1 will be equals to the V2 as well. Okay, V1 equals to V2. And what's V2? V2 is the voltage across this C2 capacitor. This C2 capacitor will have a voltage how much? V2. V2 and C2 will be the same. Sorry, V2 and V1 will be the same because these two are in parallel combination, and that would be equals to how much? 4 by 3. This is the 4 by 3 voltage. All right, so we know the voltage across this capacitor. So also we can find out that how much charge. So what would be the charge across the upper one? Charge stored in the C2. Q equals to CV. Okay, C2 into V2. C2 is how much? 12 into V2 is how much? 4 by 3. 4 4s are how much? 16. Q2 is 16 microcoulomb and Q1 was how much? 8. So what's the total charge? Total charge in this network in parallel combination. Charge is what? Charge is not the same, so we have to add up the whole charge. This is Q2 and this was, let us suppose, Q1. Q1 was given. So the net charge in this whole system, charge, net charge equals to Q1 plus Q2. Q1 is given 8 and Q2 is how much? 16. So 8 plus 16 is how much? 24, I guess. 24 microcoulomb is the charge. All right, 24 microcoulomb is the charge. In this section, let me tell you, the 24 microcoulomb charge is this whole section. Okay, I guess you can understand this properly. So this whole section and this whole section is in series combination, right? This whole section and this whole section is in series combination. So in series combination, the charge remains the same. So this particular thing will also contain the same amount of charge, that is 24 microcoulomb. Okay, I guess you can understand this properly. So we need to find out the voltage. What's the voltage? V equals to Q by C. Q is 24. We have found out 24 by C. What's the charge? 6. All right, the 6 volt is the voltage. I guess this is the answer. 6 volt is the correct answer. So this was a conceptual problem. The basics as well. This is a conceptual problem, so you can take a screenshot or note down. Okay, so let's jump on to the next question. What's the next question? Let me find out the next question. All right, so the next question is same. Find out the charge and potential across each capacitor. Find out the charge and potential across each capacitor. So this is the capacitor. Okay, this is one capacitor, this is another one, this is another section. Okay, so this is 100 volt supply. All right, so this is 5 microcoulomb, sorry, 5 microfarad. This is 6 microfarad and this is 3 microfarad. Find out the charge and potential across each capacitor. Charge and potential. You need to find out the charge and the potential as well. So try this problem and pause the video. So let's do this right now. Charge and potential. So I've taught you in the previous lecture. There is a positive terminal, the negative terminal, and the positive. Let's name this thing. The positive terminal is connected is A, the negative is terminal B. Okay, so as long as the value is same, the potential will also be the same. This is A, so this will also be A. This is B, this will also be B. Likewise, same values continuing. This will be A and this will be B. Potential across AB is 100 volt. Potential across AB is 100 volt. So this is AB and what's the potential? 100 volt. Let's find out the charge. Charge across this. Charge across this. Q equals to CV. C is what? 5. Voltage is what? 100. So 500 microcoulomb. All right. Likewise, we have to find out the charge across this branch. Okay, so for that reason we need to find out the equivalent capacitance of this branch. So what is the equivalent capacitance of this particular branch? They are in series, so we need to carry out what? 1 by C1 plus 1 by C2. This is a series. 1 by CS. S means series. Okay, 1 by CS. 1 by CS equals to 1 by C1 plus 1 by C2. So what 1 by C1 is 1 by 6, 1 by C2 is 1 by 3. So what's the LCM? 6 is the LCM. 3 to the 6, 3 upon 6. So this 1 by CS. So CS equals to how much? 2 microfarad. CS equals to 2 microfarad. So what's the charge right now? Q equals to CV. But it means across this whole branch. This whole branch equivalent is what? 2 microfarad. So right now we will apply Q equals to C times V. C is 2 and V is what? 100. 2 times 100. 200 microcoulomb. So charge is 200 microcoulomb across this branch. So this means this 200 microcoulomb will be in this particular capacitor and this particular capacitor as well, since they are in series combination, and in series combination the charge remains the same. Alright, so we have find out the first part, that is the charges, and right now we will calculate the voltage. Okay, so what's the voltage? V equals to how much? Let's calculate the voltage of this particular section. Voltage you can find out by visualizing. This is end AB, and across AB end the voltage is 100. So this is also AB. So what is the voltage? V equals to 100 volt. Okay, or you can do what? V equals to Q by C. V equals to Q by C. Q is how much? 500. C is what? 5 microcoulomb and microfarad. This will be cancelled out, and 100 volt is the voltage across this branch. 100 volt. All right, so what's the voltage across this branch? V equals to Q by C. Q is how much? 200 volt. You found out. 200 by C. C is what? 6. Okay, so 100 by 3 is the answer for this particular voltage. For this particular voltage, V equals to Q by C. Q is how much? Again 200, since series combination, by 3. This is the answer. Okay, 200 by 6 and 200 by 3. These are the answer for what? Voltages across each of the capacitors. Volt. Okay, so I guess you've understood the problem. Let's move on to the next one. And next problem says, so you can note it down, and by the time I'm writing the next problem. Okay, So next problem says C1 equals to 300, sorry, C1 equals to 3 picofarad, C2 equals to 2 picofarad. Calculate the equivalent capacitance of the given network. Okay, let's repeat the problem. C1 equals to how much? 3 picofarad. Pico means 10 to the minus 12. I guess you have learned all this in class 11 itself in chemistry. Pico, nano and angstrom. These are some basics. Okay, so C1 equals to 3, C2 equals to 2. Calculate the equivalent capacitance in the given network of systems. Okay, and the given network is like this. This is C1, this is C1, this is C2, this is C1, this is C2, this is C1. Okay, so this is the, let's suppose this is end A and end B. Find out the equivalent capacitance between the network A and B. Equivalent question, the question is equivalent capacitance, between A and B equals to how much? So you can try this problem after pausing the video. Okay, okay, so I'm solving this. C1 equals to 3, so C1 equals to 3, C1 equals to 3, and C2 equals to how much? C2 equals to 2. The C2 is 2 picofarad, and all of these are in picofarad. Pico, PF. C2 is in 2 picofarad. So let's solve this. Okay, so this branch, okay, we will approach from this branch. This capacitor, and this capacitor, these are in how much? These are in series combination. These 3 are in series combination. So in series combination, you can apply the formula 1 by Cs. All right, 1 by Cs. The S subscript denotes the series. 1 by Cs equals to 1 by C1, 1 by C2 plus 1 by C3. C1 is how much? 1 by 3, C2 is 1 by 2, and again this is C1, this is C2, and again this is 1 by 3. LCM will be, I guess, 6. 3 2 is 6, 2 3 is 6, 3 2 is 6. Okay, 7 by 6. So 1 by Cs equals to 7 by 6 picofarad. Rather, Cs equals to 6 by 7 picofarad. Okay, Cs equals to how much? 6 by 7 picofarad. So this whole network is having this amount of equivalent capacitance. Okay, 6 by 7. I'm erasing the whole thing. Now, what's equivalent? Equivalent is we can put a single capacitor in place of all these capacitors. Okay, we can put a single capacitor in place of all of these capacitors. So let's put it, a single capacitor is having how much amount of capacitance? 6 by 7 picofarad. 6 by 7 picofarad. Okay, now you can visualize that this particular thing and this particular thing are in parallel combination. So let's put the formula for parallel. Cp equals to C1 plus C2, C1 plus C2. Okay, this is 6 by 7 plus C2 is how much? 2. 6 plus how much? 14, that's 20 upon 7. This is Cp. Cp is how much? 20 upon 7 picofarad. So this two we have solved how much? 20 upon 7. Okay, so again what's equivalent? we can put a single capacitor in place of these two. We've solved right now. We can put a single capacitor of how much value? 20 upon 7. 20 upon 7 picofarad. Okay, so I guess this is quite a bit clear, as you have solved quite a lot of problems as of now. So these two are in how much? These two are in these three are in series or parallel. You can conclude as long as the wire is same, as long as they are connected by the same wire, they are in series combination. So we can put the formula for series combination. For series, what formula? 1 by Cs equals to 1 by C1 plus by C2 plus 1 by C3. So for C1 we will be 1 by 3 plus 1 by, this is how much? 20 upon 7. So 7 will be at the numerator and 20 will be in the denominator. The C3 will be how much? 1 by 3. Okay. So what will be the LCM? 60 will be the LCM. All right. 3 7s are 21 plus. So what's the answer? 61 upon 60 is 1 by Cs. So Cs equals to 60 by 61 picofarad. This is the answer for this particular thing. Okay, so I guess this is a bit clear right now. Okay, so let's do another problem, and I guess we will do the last problem of this video, and it's already 30 minutes, and shooting and uploading all of this from a mobile phone is quite a bit hard. Okay, so let's do the last problem. Okay. The problem says 3 capacitors C1, C2 and C3 are connected to a 6-volt battery. C1, C2 and C3 are connected to a 6-volt battery. So this is C1, this is C2 and this is C3 are connected to a 6-volt battery. C1, C2 and C3. This is 10, this is 5, this is 5. Okay, so this is C1 millifarad, this is C2 5 millifarad and this is C3. This to how much? 10 millifarad. No, this is again 5 microfarad. Are connected to a 6-volt battery. This is a 6-volt battery. Okay, so you need to find out the charges on the 3 capacitors. Find out the charges. Find out the charges on the 3 capacitor. Charges on each. What are the charges? Okay, so try this problem. All right, so let's do this. I guess you've tried this after pausing the video. So you can get a bit confused by watching these two. Are these in parallel or in series? So we can modify this thing, like we can place this capacitor at this position as long as the wire is same. So we can do this particular thing. We will join, this is the capacitor. Okay, so this was how much? This was 5 and this was 5 as well. Okay, so 5 and 5 are in series combination, and in series combination, sorry, my bad, these are in parallel combination. This thing and this thing, let's do this. Let's suppose this is A, this is B. So this end will be in A and this will be in B. So these two are in what? There's a branch, so these are in parallel combination. My mistake. So Cp equals to how much? C1 plus C2. C1 plus C2, 5 plus 5. So this will have a charge of, sorry, this will have a capacitance of 10. Cp equals to 10 microfarad. Okay, 10 microfarad. All right, so again these two are in connected in this. Okay, so we have to put another diagram we need to put another diagram, that is of 10 microfarad capacitor. This is a 10 microfarad capacitor, that's the equivalent, and 10 and 10 are in what combination? 10 and this are in series combination. So what we will do, 1 by CS is in series combination. 1 by C is equals to 1 by C1 plus 1 by C2, 1 by C1 plus 1 by C2, 1 by 10 plus 1 by 10. LCM becomes 10. So this is 2 by 10, that's 1 by 5. So CS equals to how much? 5 microfarad. So this is the series combination, the equivalent. The equivalent capacitance is how much? What? 5. Okay. So this is the thing. So all right. So what is the charge right now? The formula for charge is Q equals to how much? Q equals to CV. Q equals to CV, and what is the charge? What is the capacitance? C is 5. The voltage is 6 volt. So 30 microcoulomb is the charge. 30 microcoulomb is the charge, and you can conclude the charge across this and charge across this will be the same, since they are in series combination. Okay, in series combination the charge remains the same. Okay, so let's calculate potential right now. So what's the potential across this? V equals to how much? Q by C. Okay, Q is what? 30 by C. What's the capacitance? 10. 30 by 10, that means 3 volt. Okay, so 3 volt is the voltage across this particular capacitor, and we need to calculate the voltages across this as well. Okay, 3 volt. So right now, what would be the voltage across this capacitor? What is the voltage across this? V equals to how much? Q by C. Q upon C. Okay, so Q is what? 30. 30 is this. This have 30 microcoulomb of charge. This will also have 30 microcoulomb, since they are in series combination. Q is what? 30 upon C is what? 10. That is 3 volt. V equals to how much? 3 volt. And 3 volt is across this combination. So what did we do? This 10 consists of 5 and 5, right? 5 microfarad and 5 microfarad. So the 3 volt will be applied through this and this as well. 3 across this and 3 across this end. Okay, let's suppose it is AB, 3, AB, 3. 3 is consumed in this, and 3 will be remaining parallel. Okay, so I guess you've got the answer, all of the answers correctly. One more thing, we found out the voltages. This have 3 volt and this have 3 volt, and charges, we didn't find out the charge across these capacitors. Q equals to CV. So right now you need to apply it. Q equals to CV. So Q equals to CV. Q equals to C times of V. C is what? 5, and voltage is 3. 15 microcoulomb is the charge, and this will also have 15 microcoulomb charge, since voltage is this and capacitance is 5. 3 5s are 15. So that's all for today's video, and for more such videos, please like, share and subscribe to the channel, and you can take a screenshot and share this with your friends, those who are struggling with physics, and you can ask your doubts in the comment section, and on Instagram as well, at the @GSha Physics and at the @BMB Galib. Thank you and have a great day. Although you can check out the comment section for the Instagram, and that's it.